Okay, so we are taking a deep dive into infrasound, and it's by our team, Katie, Anna, and Gigi.
Okay, so what is infrasound? Infrasound refers to the sound waves that have frequencies below the lower limit for humans to hear. So it's typically under 20 hertz.
There are various technologies that use infrasound, and some of them, for example, are used for detecting bombs. Others are for aircrafts. Others are for natural disasters. There's a whole array of them. So the first one here, the infrasound detection system, that particular one is used to detect avalanches. And so the picture that is being shown here is one of these systems. And it's in a really strategic spot because there's a road that is pretty nearby. And if there's an avalanche, they can notify people so that they're not passing through and there isn't like a huge issue. And so, as you can see, the group that kind of is in charge of these different stations throughout the world was an avalanche control. Then you have NASA with their infrasound sensor technology, and that is mainly with aircrafts. And so often when an aircraft takes off, there's the possibility, I believe it's a 10% possibility that there is like a weird effect that could inhibit other people from taking off. So this helps make sure that it isn't actually happening and that if indeed this weird effect is happening, the pilot of the next aircraft is going to wait approximately 3 minutes for everything to dissipate. And then there's CTBTO, which is a company based in Vienna, and they have set up various infrasound monitoring stations, and they work more or less, they'll take in infrasound specifically for bombs or nuclear bombs or whatever it might be, and then they'll send it through a complicated transfer of energy and waves to a radio tower that will transmit it to a satellite that will transmit it to the command station. So here it's taking a little bit of time to load, but it's a video that's done by CTBTO, which explains how everything works more in depth if you are interested. But for now, we are just going to continue with the slides. Okay, so some of the benefits for humans. As I've already mentioned, detection of natural phenomena or of issues with aircraft, takeoff, whatever it might be. So it's going to alert whoever's in charge at the command station, and so they can send that out if it needs to be broadcasted nationally, or if it's just in a little area, or just for data reasons, they can have those alerts. It also provides security, especially if there's a natural disaster such as a hurricane or I don't know, an earthquake or a volcano erupting. And so that all is really important. And so these first three are really helpful for humans. Then communication is mainly for animals, but I wanted to mention it anyway, even though it doesn't impact humans that much. And so there's several animals that use this type of communication. Some of them include whales, octopus, cats, giraffe, and there's several others that communicate with these really low frequency sound waves.
Okay, so energy that is involved in like the infrasound technology is acoustic energy, which is like the main one, and it's also known as sound energy. And it's basically um it is that energy that is caused from vibrations. So like It's caused from a mechanical process, and well, those vibrations are like manifested or like shown through infrasound. Then it's mechanical energy, and like I said, like infrasound waves are generated by a mechanical process, which is like a movement of a large object or a natural phenomena, just like earthquakes, or just like man-made sources, which can include machinery explosions. And well, mechanical energy produced from like these sources is converted into acoustic energy. Um, and then there's electrical energy. So infrasound waves or like infrasound is measured using like sensors or microphones, and that converts acoustic energy into electrical signals, which helps them be like uh, analyzed, let's say. And then there's potential and kinetic energy. And basically, it's just like the particles that are in the medium through which infrasound waves travel. They both have potential and kinetic energy. Potential because of where they are, like where they're positioned, and kinetic energy due to their motion. There's energy transfers, which I kind of explained already. Mechanical energy gets turned into acoustic energy when the infrasound waves are generated. Acoustic energy uh, gets transformed into kinetic or potential energy when going through a medium, and acoustic energy gets transformed to mechanical energy, which then gets converted to electrical energy so that it can be analyzed or so that it can be analyzed and used, and that's like in sensors. And then there's like acoustic energy that ends up being thermal energy because it just got like lost in the way, so it it doesn't like get destroyed, it just ends up turning into thermal energy. And then like in infrasound, it just like different transfers of energy occur at various points in time. So like there's many energies involved with when using technology for infrasound, and that's why there's like so many options of how you can use that technology because of how many much type of energies occur when with infrasound.
Okay, so how do waves help infrasound technology function? Well, overall, infrasound technology mostly relies on waves to detect, track, and analyze the low frequency vibrations. And usually, when an event occurs, it generates an infrasound waves that travel through the air, and they are picked up by sensors that that are placed at different locations. And by measuring how and when the waves reach each sensor, scientists can determine the event's source and the location. Um, and also, since every natural event produces a, a unique infrasound pattern, you can analyze these waves, and it helps you classify the events and improve in the detection systems to help like prevent uh it to be like really terrible. And yeah.
Okay, so we're going to talk about infrasound properties, and I'm only going to use this picture because it basically sums up everything that needs to be known. So as you can see, infrasound is categorized from 20 hertz and lower. So it's barely perceivable by the human ear. It is perceivable. I've tested it, and it does work, but it's very painful to listen to. And so, as you can notice, at least in this particular diagram, the amplitude does not vary, and that's simply because this is all in one medium. If there's a change in medium, amplitude will differ, but in in and of itself, infrasound is not going to cause an issue in terms of differences in amplitude. It's really if they change medium. And then on top of that, wavelength, as you can observe from this beautiful diagram, the wavelength is significantly longer, and that's because it's inversely proportional to the frequency. So when the frequency is super tiny, the wavelength is going to be way longer. So that's why we see it's spaced out a lot more than, let's say, ultrasonic sound.
So longitudinal waves. I'm gonna give a brief explanation, which is like longitudinal waves are waves in which the particles in which the particles of the medium vibrates parallel to the direction of the wave transmission, and that's the type of waves like infrasound waves are, and this is like because um infrasound waves are the sound waves. There are a type of sound waves, and all sound waves are longitudinal waves. We can also identify that these are longitudinal waves because of the way they propagate or transmit, which is through compressions and refractions, and how they are detected, which is pressure and sensors.
That's everything for today. Thank you so much for listening to us, and we hope you enjoyed the video.
Thank
Bye.
you. Bye.
Bye.